Okay, so you can see my screen, right?
Yes, miss.
Okay, let's continue. So we were discussing equation of a line through a given point and parallel to a given vector. So this was the equation of a line in vector form, which is parallel to a given line and passing through a point. Suppose we have taken the coordinate of the point as a x1, y1, z1, and let's say a random point P is over there on the line. Okay, just focus on this statement first. Okay, so we are discussing equation of a line. Equation of a line through a given point and parallel to a given vector B. Okay, equation of a line passing through a point and parallel to a given line. Okay, so here we have, as you can see in the figure, that we are having a line. Here we are having a point A, equation of a line we want to find passing through point A, and we have assumed that the coordinate of A is x1, y1, z1. Okay, similarly, uh, here one straight line is there. Okay, and we have taken the position vector of the parallel line as a B. Here we have taken a random point P, and let's say the coordinate of this random point, which is on the line. Okay, the line through which, uh, this point A is there on a line. So this random point is P is also there on the same line L, as you can see in the figure. Now the coordinate, we have assumed that B, let's say we are having AI, BJ, CK. A the position vector B is AI plus BJ plus CK. The position vector A and the position vector R, everything we have written over here according to the coordinate we have assumed. Now this is the vector form of the line. Okay, in this vector form is lambda p is equals to r minus a. In this vector form, if we will substitute the position vector of each and every line, then each and every point A, P, and the other line, then we will get the Cartesian form. Let me show you. We will just get back to this question after a while, after writing the Cartesian form. So in 2D geometry, how you have seen the equation of line, it used to have x, y. The equation of line used to be in the format of 2x plus 3y is equals to something. So x and y used to be there. So here we will be having r. Okay, when we will write the Cartesian form. So let me write it. So vector form is lambda p is equals to r minus a. We are saying, let's say b is ai plus bj plus ck is equals to r, that is xi plus yj plus zk minus a, that means x1i plus y1j plus z1k. Okay, let's continue. So here we will be having lambda ai plus lambda bj plus lambda ck is equals to xi is there and minus x1i is there. So xi minus x1i, I am writing it together, then we'll be taking common I. Okay, yj minus y1j plus zk minus z1k. Here we can take out common the unit vector I, x minus x1, the unit vector z, y minus y1, and the unit vector k, z minus z1. Here we will be lambda ai plus lambda bj plus lambda ck. Now if you will compare both sides with if you will compare the corresponding unit vector, this I with I, z with z, and k with k, let's see what are we going to get. So lambda a is equals to x minus x1. We will be getting lambda b is equals to y minus y1, and we will be getting lambda c is equals to z minus z1. So if we'll find lambda value here, lambda is equals to x minus x1 over a, lambda is equals to y minus y1 over b, and here lambda is equals to z minus z1 over c. Now all are the value of lambda. So we can say x minus x1 over a is equals to y minus y1 over b is equals to z minus z1 over c. This is the equation of a line passing through a point. That point coordinate we have taken as a x1 y1 z1. So this is the equation of a line in Cartesian form. This line is passing through a point A. That A point coordinate was x1, y1, z1, and it was parallel to another line whose direction ratios are A, B, and C. Okay. So in Cartesian form, if we have to find the equation of a line passing through a point parallel to a given line, so this equation, this format we will be using. Okay, now let's solve few questions related to it. So if the question is find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i plus 2j minus 2k. We have to find the equation of a line which is passing through the point this one and is parallel to this line. We know the Cartesian form of equation of a line passing through a point parallel to another line is this one. So Cartesian form easily we will be able to write, that is x minus here x1 y1 z1. This one is x1 y1 z1, and this parallel vector here, this is a value, this is b value, this is c value, the direction ratios. Okay, so let's write the equation of a line. Easily we will be able to write the equation of a line will be x minus x1. What is our x1 value? 1 over a value is 3 is equals to y minus y1, y minus what is y1 value? 2 over b value, that is 2 is equals to z minus z1. Z minus z1 is 3 over c value, that is negative 2. So Cartesian form of a line, Cartesian form for the equation of a line will be this one, which I have written over here, which I am just keeping it in rectangular box. Okay, we also have to write the vector form. So let's see what will be the vector form of equation of a line. So now only we have discussed the vector form will be, the vector form will be equation of a line passing through a point parallel to another line will be lambda b is equals to r minus a. You must know what is b, what is r, what is a. Okay, so lambda b is equals to r minus a. Okay, so here what was b? B was the parallel line. What was a? A was the position vector of the point A. Okay, it was x1 y1 z1, and a from origin the position vector. Okay. Yeah. So lambda b is equals to r. What was r? R was a random point p on the line, and that's coordinate we have taken as a x, y, z. So these things must be clear to you. Okay. A, this is A, this is R, and this is B. Okay. So vector form we have to write. So B means AI plus BJ plus CK. R XI plus YZ. Let's keep R as it is, because in two dimension, in 2D geometry we used to have equation of a line in terms of x and y. The equation of a line was y minus y1 is equals to y2 minus y1 by x2 minus x1 in bracket x minus x1, and then when we used to solve it by putting the value of x1 y1 x2 y2, then we used to have an equation of a line in this format. Maybe 2x plus 3y is equals to 7, or maybe in the format of y is equals to mx plus c, that is 20x plus 30, or maybe y is equals to 5x plus 2, where this 5 used to denote the slope of the line and this 2 used to denote the y-intercept. So this was the format of equation of a line in 2D geometry. Here we will be having equation of a line whenever we will be finding in vector form. It will always be having r. Okay. So let's keep r as it is. So we are having lambda b ai bj ck, that is already given as a 3i plus 2j minus 2k. Let's substitute it. 3i plus 2j minus 2k. Why I'm substituting b as this line? Because it is written b, we know, represent the parallel line, and here in the question also it is written that parallel to the vector this one. Just concentrate on this statement, parallel to the vector this one. Okay, that's why we are saying this is b. Okay. Now is equals to r. As I said, our equation of a line will be in terms of r minus a. What is a? A, you can see a means position vector of a point A, that is x1 y1 z1 was the coordinate, and here it is x1 y1 z1, the coordinate is 1 comma 2 comma 3. So a will be I plus 2z plus 3k. Is it clear so far? What exactly are we doing? Is it clear? Anyone? Any doubt? Okay, let's continue. Let's solve it. So we will be having r is equals to lambda 3i plus 2z minus 2k plus I minus 2z. Okay, this total we are substituting over, just shifting over there. So no need to change the sign, plus 2z plus 3k. Okay, directly we have changed the sign of this one. This negative became positive over here. That's it. So r will be, if we will take the unit vector I as a common, if we will take unit vector z as a common, if we will take unit vector k as a common, so directly we can write over here. We can write 3 lambda from here and plus 1 from there, that I cap, plus 2 lambda plus 2 z cap minus 2 lambda. So if you want to write plus over here, then you have to write minus 2 lambda like this, and plus 3, that is k cap. This is our equation of a line, the same line equation in vector form. Let's summarize the whole thing, what we have done over here. So find the equation of a line which passes through a point. point is given and is parallel to the given vector. Okay, so equation of a line passing through a point parallel to a given vector in Cartesian form, the formula is x minus x1 over a is equals to y minus y1 over b is equals to z minus z1 over c, where a, b, c are direction ratios, x1, y1, z1 direction ratio of a parallel line, and x1, y1, z1 coordinate of the point. The line is passing through a point. That point's coordinate is x1, y1, z1. We have just substituted in the point and the direction ratio. We got the equation of a line in Cartesian form. Now, equation of a line in vector form. The equation of a line in vector form for this condition, that is passing through a point parallel to a given vector, is lambda b is equals to r minus a. Okay. So, uh, what are we doing? We are just putting the value of b, we are putting the value of a, r we are keeping as it is. As we know, in 3D geometry, our equation of a line in vector form will be having r. Okay, so this, after substituting everything and doing few arrangements, we have got the equation of a line in vector form as this one. Now the other concept over here is, okay, one very basic question is there, that is the Cartesian equation of a line of a line is x minus 5 over 3 is equals to y plus 4 over 7 is equals to z minus 6 over 2. Write its vector form. Now only we have done the same thing, but there the coordinate was given and the parallel line in vector form it was given. Here we have to identify, okay, this one is x1 value, this one is y1 value, this one is z1 value, this is a, this is b, this is c. Now we have to write it in vector form. What was the equation of a line in vector form? It was lambda b is equals to r minus a. Lambda b is equals to r minus a. We don't have to worry about r. B and a we have to identify. What was b? Let's see in the figure. As you can see, a is the position vector of a point a. A is the position vector of a point a, that will be x1i plus y1j plus z1k. Do we know x1, y1, z1? Yeah, we know. Okay, this is x1, this is y. Anyone asking anything?
I'm like, we don't have to simplify, right?
What? We don't have to?
We don't have to simplify, right?
Yeah, we just have to put the value, and r we will be keeping on one side, and that's our equation of a line. Nothing we have to do. Getting it?
Yes.
Okay. B, what is B? B means AI plus BJ plus CK. What is AI? A is 3I plus BJ is 7J plus CK is 2K. Okay, we will be putting the value and we will be getting the equation of a line. Is it clear? In vector form. Now the next concept over here is, if you are having any doubt, please tell me. I'll take a pause and will explain. Now, equation of a line passing through two given points. So, equation of a line passing through two given points. Here we were having one point and one parallel line. And that equation was, you should keep this formula and everything in your mind. Now, equation of a line passing through two given points. The same way we will be having, let me draw the figure. So, y, z, x. Suppose here we are having one, okay, Here we are having 2 points, that is point A and point B. Equation of a line passing through two given points. The points are point A and point B. Now the point A, we have taken the position vector as a A. Here also B we will be taking as a B. So previously we were representing B, like the parallel line we were representing by B. Here we are representing the another points position vector by B. Okay, now here also we will be taking a random point P and that's position vector, let's say be R. Now the equation of a line directly I am writing in Cartesian form, it will be, as you know, just like the previous one, the previous one was x minus x1 by A is equals to y minus y1 by B is equals to z minus z1 by C. Here we will be having x minus x1 over x2 minus x1 is equals to y minus y1 over y2 minus y1 is equals to z minus z1 is over z2 minus z1. This is the equation of a line passing through two points in Cartesian form. What about vector form? So vector form will be r is equals to a plus lambda b minus a. Okay, this is Cartesian form. This is vector form. The way we have solved the equation, the way we have solved the question related to the previous concept. Similarly, here also you will be able to solve the question. Just try to solve it from the exercise, and in the next class, do let me know whether you were able to do it or not. Let's move to the next concept because this one is just exactly same like the previous one. You will be having the coordinate, you will be having everything. You just have to put the values in the given formula, in the formula which I have written, and you will be getting the equation of a line in Cartesian form or in vector form. Here you should know what is B, what is A. Here A. Okay. If this is clear to you, then definitely you just have to put the values or the position vector. Now the next concept which I wanted to discuss today is skew lines. So lines which are neither parallel nor intersecting. So two lines which are neither parallel nor intersecting are called skew lines. So here we are talking in 2D geometry. You have learned that if we are having two lines, then the two line must be either parallel or will intersect each other. So in 2D geometry, if we are having two lines, just basically two lines if we are having on the screen on the paper, then that two line we will just extend it, then either it will end up intersecting each other, or if it will not intersect at all, then that means these two lines, distance between these two lines is always same, and these are the pair of parallel lines. This was the condition in 2D geometry. Here we are learning about 3D geometry. Here we will be having such line in different planes which are neither parallel nor intersecting. Okay, so let me draw such line. Just a moment. Okay, so if I am having this figure, just a moment. Let me show you on the screen so that you can visualize it in a better way. Can you see my screen? Can you see everyone?
Yes.
This is the example of skew lines. Okay, you can see these two lines are on different plane, and these two lines are neither intersecting, and it's not parallel lines also. One is going up, it will go up, another is going this way, so it will never ever intersect with each other. And yes, these two are not at all a parallel lines. So this one is the example of skew lines. Okay, as per the definition, these two lines are the pair of skew lines. Now here we will be finding now here we will be
Ma'am,
yeah.
like they lie in different plane.
Yeah, they lies on different planes. In 3D geometry, if we are talking about, then we can assume a box, we can assume a cube, we can assume a cuboid. So one line on the like another surface, one line is there, and another line is on the another surface. In such a way that they will like both the line will not at all intersect with each other, and yeah, both the line we can't say it's a parallel line. Are you getting it?
Yes.
So here we will be finding the distance between just a moment. So here we will be discussing the shortest distance between two skew lines. In vector form, the formula for shortest distance will be, suppose two lines which I have shown in the figure just now. Suppose the equation of that lines are r is equals to a1 plus lambda b1, and another one is r is equals to vector a2 position vector plus mu, where lambda and mu are nothing but a real number, mu b2. Then the equation of a line, the shortest distance between these two lines will be d will be b1 cross b2, the cross product between b1 and b2 multiplied with a2 minus a1 over b1 cross b2, the magnitude of this one. Okay, and in Cartesian form, when the line equation of a line L1 and L2 is x minus x1 over a1 is equals to y minus y1 over b1 is equals to z minus z1 over c1, and L2 is x minus x1, x minus not x1 because we have taken that, x minus x2 over a2 is equals to y minus y2 over b2 is equals to z minus z2 over c2. If these two are equation of a line in Cartesian form, the same skew lines I am saying, then distance between, or we will say the shortest distance between both the lines will be x2 minus x1 y2 minus y1, z2 minus z1, here a1, a2, b1, b2, c1 and c2. Okay, let's solve few question. Yeah, this is the determinants we have to find: x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 over square root of this one, b1 c2 minus b2 c1. This is not negative, this is not negative. b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. How you will memorize this, or how you will keep it in mind? You can see this one is just the way we solve the determinant b1 c2 b2 c1. Okay, similarly other one, if you will see, it's just the same. Okay, this one c1 a2 c2 a1, how we do, we just multiply this with this and this with this, right? So same thing I have written over here. The last one is also the way we solve the determinants, that only I have written a1 b2 minus a2 b1. Okay, this way you can keep it in mind. Now let's solve few questions so that you will be able to understand how exactly we are going to use the formula. Just give me a second. Let me take few, like a question from NCRT. Yeah, the question is, find the shortest distance between the line L1 and L2 whose vector equation of R is equals to I plus J plus lambda 2I minus J plus K, and another one is R is equals to 2I plus J minus K plus mu 3I minus 5J plus 2K. Okay, these two are vector equation. We have to find the shortest distance between these two lines. Let's see what is the formula for finding the shortest distance between two skew lines. Whenever the vector equation is given as a r is equals to a1 plus lambda b1, r is equals to a2 plus lambda b2, be careful whenever we are talking about the skew lines, here b1 and b2 will be given. Okay, now only we will go for parallel line also. What is the difference between skew lines and parallel line? I'll show you just after a while. So here the formula for shortest distance is D is equals to B1 cross B2 dot A2 minus A1 over B1 cross B2, whatever we have found, that's magnitude. Let's write the formula. So what is B1? What is B1? So now only I have shown you, here we were having B1 and here we were having B2. Okay, compare it with the formula which I have written, lambda B1 mu B2. So B1 and B2, it's very simple to identify. Here We are having B1 as a 2i minus j plus k and B2 as a 3i minus 5j plus 2k. What is A1 and A2? So the first part is A1 and the next one is A2. So this one is A1, this one is A1, okay, and another one is A2. If you are getting confused, let me write it over here. The equation of a line in vector form was in the format of R is equals to A1 plus lambda B1. R is equals to A2 plus lambda B2. Okay, this was the format, and on the basis of that I am saying which one is A1, which one is A2, which one is B1, which one is B2. So our A1 is I plus J, that's it. A2 is 2I plus J minus K. What is B1? B1 is 2I minus J plus K, and B2 is 3I minus 5J plus 2K. Okay, accordingly, we will substitute the values in the formula. What the formula says, we have to find the cross product. Please find the cross product between B1 and B2 and answer it in the chat box that what exactly are you getting. B1 cross B2. Okay, B1, B2, it's clearly visible on the screen. Do let me know what exactly are you getting after doing the cross product of B1 and B2. Everyone do it on pen and paper, and just if you want you can unmute yourself and answer it, or you can also write the answer in the chat box. Do it. Meanwhile I'm selecting another question. Three I minus j minus 7k. Everyone is getting the same. 3I minus j minus 7k. Check it. Yes, exactly. We will be having B1 cross B2 as a 3I minus j minus 7k. Okay, everyone must get this one. Mm. Dot product A2 minus A1. What is A2 minus A1? Check it. Yeah, what is A2 minus A1? A1, A2, everything is mentioned on the screen, and the formula also you know. A2 minus A1. It's I minus K. Let me check. Everyone is getting the same. Only Sivas is responding. No one else is responding over here. Please tell me, are you getting the same for the previous one, B1 cross B2, and for A2 minus A1 also? Yes, it's correct. It's perfect. Okay. You have got I minus K, right? Yeah. Now we will be doing, like, we will just substitute everything over here. So we will be having 3I minus J minus 7K and dot product I minus K over B1 cross B2. So we will be finding the magnitude. That means under root, what, 3 square, that will be 9 plus 1 plus 49. Are you getting under root 59 over here? Now, when we'll be finding the dot product, it will be 3 and times 1, 3 minus 1, and here no z is there, that means 0. Okay, so negative 0 minus 7 minus 1 will be plus 7 over root 59. So, answer will be 10 over root 59. That is the shortest distance between the given two lines, the given two skew lines. Okay. Similarly, here we are having the formula for shortest distance between two parallel lines. The same for format like in vector form, if r is equals to a1 plus lambda b. Here, this is also b, this is also b, because these two lines are parallel lines. Okay, previously it was skew lines, the pair of skew lines. So the formula for this is b cross a2 minus a1 over the magnitude of b. Now, if we will take one question related to this, let me take it. Find the distance between the lines L1 and L2 given by R is equals to I plus 2Z minus 4K plus lambda twice I plus 3Z plus 6K, and the other one is 3I plus 3Z minus 5K plus mu 2I plus 3Z plus 6K. As you can see, if you will focus on the given vector equation, you can see this one and this one is clearly given as a same. So obviously these two line are pair of parallel line. Previously, if you will get back to previous question, you can see this one lambda, whatever was multiplied with lambda, and this one was different. Okay, so this two pair was not parallel line, it was skew lines, and we have applied the formula for skew line. Here we will be applying the formula for parallel line. What is the formula for parallel line? Here I have written just now when you were solving the uh, like b1 cross b2 and everything, a2 minus a1, then I have written this formula. It is just like the previous formula, little bit moderation is there. So what we will be doing, we will write vector b cross a2 minus a1. What is our vector b? Our vector b is 2y plus 3z plus 6k cross b2 minus a2 minus a1. So this one is a2, this one is a1. If we will find a2 minus a1, 3 minus 1 will be 2y, 3j minus 2z will be only j, positive, and minus 5k minus of minus 4k. If we will do minus 5k plus 4k, we will be having, that is negative k. Okay, this is our a2 minus a1 over the magnitude of b. We will be finding, that is b is, this is b. Okay, this is vector b. So magnitude will be 2 square 4, 9, 49, that is 7. So we will be having 7 over here. Okay, let's find the shortest distance. So it will be cross product, again we have to find. Please find the cross product and tell me what are we getting. The numerators one. Everyone please take your time and do the cross product which we are having in the numerator, as you can see on the screen, and let me know what exactly are you getting. Everyone, I'm expecting a response from everybody. Okay, so either you can unmute yourself or please write the answer in the chat box.
This is cross product, right?
Yeah, what? What you said? Please, can you please repeat it?
This is cross product, right?
Yeah, this is cross product. This two, this one and this one. What are you getting? Everyone is
What is the
doing
same
the
answer?
same. Are you getting this one? Negative 9i plus 14j minus 4k.
Yes, sir.
Okay. Here, here as you can see, the formula here we are having the modulus, you can say, or here we are having, we have to find the magnitude. Whatever we will be getting, that's magnitude we have to take. Previously we were just getting the numbers, so magnitude, like everything's magnitude of the numerator and the denominator, it was not making sense, because we directly after doing the dot product we ended up getting the number 10 by root 59. Here we are getting distance. When I'm talking about the distance between, uh, suppose point A and point B will be 10 centimeter. Distance between something will be a number. Okay, so we are expecting our answer as a number. Here the formula, in the formula, this sign represent whatever we are getting. We have to find the magnitude of that. Okay, magnitude of this vector, whatever vector we have got. So we have got minus 9i plus 14j minus 4k, and in the denominator it's 7. So it's already a number, no need to worry about that. We can take out 7. But the upper one, the numerators part, we have to find the magnitude of that. And that's magnitude will be, do let me know. Are you getting root 293 over 7? Check it. Are you getting root 293? Are you? Yes or no? Everyone, are you getting root 293? We are having minus 9i plus 14j minus 4k. Okay, this is the vector we are having. That's magnitude if we will find. Are you getting root 293?